Hello students, in the previous module we discussed about what a computer is, its generation and evolution, its applications and its types. In this module we will examine the building blocks of a computer and its functional units. We will also dissect into the CPU, memory, input output subsystems to a certain depth. Let us have a quick recapitulation of what a computer is. A computer processes data into information. Data can be text, numbers, pictures, sound and graphics. They can solve highly complicated problems quickly and accurately. Carefully examine the figure depicting a computer. A computer can generally perform 5 major basic operations or functions irrespective of their size and make. They are: it accepts data or instructions by the way of input, it stores data, it can process data as required by the user, it gives results in the form of output, and it controls all operations inside a computer. Moreover, computers differ based on their data processing abilities. They are classified according to size, purpose and data handling. According to size, computers are classified into supercomputers, mainframes, mid-range computers, personal computers and personal device assistants. We have already discussed them in our previous sessions. Coming to purpose, computers are either general purpose or specific purpose. General purpose computers are designed to perform a range of tasks. They have the ability to store numerous programs, but lack in speed and efficiency. Specific purpose computers are designed to handle a specific problem or to perform a specific task. A set of instructions is built into the machine. According to data handling, computers are classified as analog, digital or hybrid computers. Analog computers work on the principle of measuring, in which the measurements obtained are translated into data. Modern analog computers usually employ electrical parameters such as voltages, resistance or currents to represent the quantities being manipulated. Such computers do not deal directly with the numbers, they measure continuous physical magnitudes. Digital computers are those that operate with information, numerical or otherwise, represented in a digital form. Such computers processes data into digital value in zeros and ones. They give results with more accuracy and work at a faster rate. Hybrid computers incorporate the measuring feature of an analog computer and counting feature of a digital computer. For computational purpose, these computers use analog components. Now let us discuss each component of a computer in great detail. Hereafter, whenever we refer to the word computer, we always mean the digital computer unless otherwise mentioned. What you see in this figure is the basic building blocks of a computer and how they are interconnected using buses. So, there are 3 major basic building blocks of a computer. The first is the CPU, also called the central processing unit, and it is implemented as a microprocessor, and this is the brain of the computer. Here is all the computations that take place, and this CPU is also responsible for controlling the entire computer. The second subsystem is the memory or the random access memory, where the CPU accesses both instructions and data. Memory subsystem is very important, since the memory subsystem holds the temporary working data of the CPU. Whatever the CPU is currently working on, the data is stored in the memory and the data is also updated in the memory. This memory subsystem consists of memories like cache memory and random access memory. So, we will see them in detail as we go along. The third I/O subsystem, third is the I/O subsystem of a computer to which all the peripheral devices are connected. So, I/O refers to input and output. So, as we already discussed in previous module, a computer gathers input from the user through various devices, input devices like the keyboard, the pointing device called mouse or joystick or any other device. And generally the computer sends the output to output device, which may be a CRT monitor or it could be a printer or any other system. Another very important component of I/O subsystem is the secondary storage device, that is the disk, where the data is permanently stored or the data is persistent in a disk, whereas in the memory subsystem or the RAM, the data is not permanent, it is volatile. So, these three components of the computer, namely the central processing unit, the memory subsystem and the I/O subsystem, all work in tandem to make the computer work as a whole. These three components of the computer are communicating with each other through bus. There are three types of buses, namely the address bus, the data bus and the control bus. The address bus carries the address of the devices in the I/O subsystem as well as the address of the location in the memory subsystem, using which the CPU can reference a particular data in the memory or the I/O. Whereas, the actual data is exchanged between the CPU, the memory or the I/O subsystem using the data bus, and the control bus is used by the CPU control unit, which used to issue control signals like read, write signals to the memory subsystem or the I/O subsystem. So, this is a gist of the building blocks of a computer. Now, what is input? This is the process of entering data and programs into the computer system. You know that computer is an electronic machine like any other machine, which takes as input raw data and performs some processing, giving out processed data. Therefore, the input unit takes data from us to the computer in an organized manner for processing. What is memory? The process of saving data and instructions permanently is known as storage. The data has to be fed into the system before the actual processing starts. It is because the processing speed of the central processing unit or the CPU is so fast that the data has to be provided to the CPU with the same speed. Therefore, the data is first stored in the storage unit for faster access and processing. This storage unit or the primary memory of the computer system is designed to do the above functionality. It provides space for the storing data and instructions. This storage unit or the primary memory of the computer system is designed to do the required functionality. It provides space for storing data and instructions. The memory unit performs the major functions like all data and instructions are stored here before and after processing. Intermediate results of processing are also stored here. Next, we move on to the brain of the computer, the CPU. The task of performing operations like arithmetic and logical operations is called processing. The central processing unit or the CPU takes data and instructions from the memory unit and makes all sorts of calculations based on the instructions given and the type of data provided. It is then sent back to the memory unit. Where does the output come from? This is the process of producing results from the data for getting useful information. Similarly, the output produced by the computer after processing must also be kept somewhere inside the computer before being given to you in human readable form. Again, the output is also stored inside the computer for further processing. What is control unit? The manner how instructions are executed and the various operations are performed. Controlling of all operations like input, processing and output are performed by the control unit. It takes care of step by step processing of all operations inside the computer. Now, let us visit the functional units of a computer. So, here we see the central processing unit in much detail. So, as I already said, it is the brain of the computer, and here we see that it has some blocks. When we go in depth into the central processing unit, we see some more blocks, that is, the CPU consists of the registers and combinational logic. The combinational logic is the circuit that is required to implement the various arithmetic and logical operations. This is also called the ALU, arithmetic logic unit. The CPU also has registers. The registers are meant to keep temporary data in the storage, because accessing data from the registers is very fast. So, generally a CPU keeps very data that is being used for computation, temporary data that is being used for computation in the registers, so that they can be accessed very fast. As I said before, the control unit is actually responsible for coordinating the working of the entire computer system by issuing control signals, and it coordinates the working of the CPU with the memory and the I/O subsystem. And data to the CPU is provided by the main memory. The main memory here is represented by the semiconductor memory, that is the random access memory, the RAM, and faster memory called the cache. So, this whole thing put together is the schematic diagram of the CPU, which represents the brain of the computer. In order to carry out the operations mentioned, the computer allocates the task between its various functional units. The computer system is divided into 3 separate units for its operations. They are arithmetic logic unit or ALU. After you have entered your data through the input device, it is stored in the primary memory unit. The actual processing of the data and the instructions are performed by the arithmetic logic unit. The major operations performed by the ALU are addition, subtraction, multiplication, division, logic and comparison. Data is transferred to ALU from storage unit when required. After processing, the output is returned back to the memory unit for further processing or getting stored. The control unit. The next component of the computer is the control unit, which acts like the supervisor, seeing that the things are done in proper fashion. Control unit is responsible for coordinating various operations using time signal. The control unit determines the sequence in which computer programs and instructions are executed. Things like processing of program stored in the main memory, interpretation of the instructions and issuing of signals for other units of the computer to execute them. It also acts as a switchboard operator when several users access the computer simultaneously. Thereby, it coordinates the activities of computers' peripherals equipment as they perform the input and output. The ALU and the CU of a computer system are jointly known as the central processing unit. You may call CPU as the brain of any computer. It is just like the brain that takes all major decisions, makes all sorts of calculations and directs different parts of the computer functions by activating and controlling the operations. Having seen the basic outline of the computer, now let us take a closer look at the figure which depicts the outline of the central processing unit of a computer. So, here as we have already discussed, so we find that the instructions are stored in the main memory. The CPU fetches the instructions one by one. There are registers in the CPU and a special register in the CPU called the program counter, which actually keeps track of fetching the instructions from the main memory, and these instructions are executed by the CPU. There are other registers in the CPU like the instruction decoder that decodes an instruction fetched from the main memory and issues appropriate control signals for fetching the data and executing the instructions, and after that storing the results. And all the coordination between this fetching the instruction, decoding the instruction, fetching the data, then executing the instructions and writing back the results to the output device is all coordinated by the control unit. So, this all things go in a synchronized fashion by controlled by the central processing unit. Now, you have understood the important role of CPU. It is in fact the brain of the computer. Now, let us turn our attention to the other subsystems of the computer, namely the memory subsystem and the input output subsystem. The memory subsystem is another important component of the modern digital computer. It should be carefully designed, otherwise the overall performance of the computer system will degrade considerably. Carefully observe the figure. You can see clearly that this picture shows you the memory subsystem of a computer. The memory hierarchy can be visualized as a pyramid. Okay. So, where the top of the pyramid refers to the storage of which are implemented by the registers inside the CPU. We have already seen that the central processing unit has a set of special storage devices called the registers. The registers are the fastest memory for the CPU. All temporary working data is stored in the register. The next level of memory hierarchy is the faster random access memory, we call them cache. A cache memory is used to store the instructions or data that are frequently accessed by the CPU. And below the cache, at the base of the pyramid, you will see the random access memory, that is the main memory, the RAM what we call for the storage of your temporary data. So, this memory hierarchy is very much essential for the proper working of our computer system. As you know that the speed of the CPU or the central processing unit is very fast, and therefore, the data has to be fed to the CPU at a faster rate. This can be made only possible by engaging a memory hierarchy as shown in the figure. So, here in the figure you can see on the left side that you have the CPU and you have a cache memory in the middle and the main memory at the other end. The main memory is bit slow compared to the speed of the CPU. Therefore, we have to match the speed of the CPU and the main memory using a faster small memory called the cache memory. So, in modern processors, the single level cache is now replaced with multi-level cache. So, we have a CPU and the main memory, and in between we have a multi-level cache where we have level 1 and level 2 and level 3 cache. So, level 1 cache is generally built inside the CPU itself in our modern processors, whereas level 2 and level 3 they are outside the CPU, but they are smaller in size and but very fast memories. So, engaging a memory hierarchy shown in the figure alleviates the problem of the memory latency, that is the latency is the decrease in speed of memory of, that is the main memory. Computer memory systems typically consist of a 4 level hierarchy, as I said: registers, cache, main memory and disk. Note that data is moved between the cache, main memory and disk transparently, but data movement between registers and the rest of the memory is explicitly under the control of the program. It is up to the compiler to decide which data items should be moved to registers and when, and the compiler must compile it into the code, the relevant load and store instructions. In practice, many computers introduce another level into the hierarchy. They have two levels of cache, a small, perhaps 64 KB, that is 64 kilobyte very fast cache memory on the processor chip called the first level cache, and a larger, perhaps 512 kilobyte memory second level cache either on the processor chip or on a separate chip, and the intermediate in speed between the on chip cache and the main memory. Now, we come to the input output subsystem of a computer. As we have already discussed, computer receives input data from a variety of devices like keyboard, mouse, joystick, and the secondary storage device, that is the disk, and sometimes optical devices like our CDs, compact discs, are also come under this category. So, the input output subsystem takes care of reading data or writing data to such devices. Devices like keyboard and mouse, they are character devices, that is they send and receive information in terms of characters, whereas those like disks and our CD drives, they send data in blocks. So, these things are coordinated by this IO subsystem. In fact, the IO subsystem and the CPU are connected by this data bus and the control bus, and of course, the address bus. The address bus decides the address of which device to access the data from, or to which device the data has to be written to, and the control line decides whether you want to read a data or whether we want to write a data. So, once these two are enabled, the data bus actually carries the data either to the CPU from the device or to the device from the CPU in either way, and which are latched, or there are special registers called latch in the IO subsystem, wherein the data is latched for either writing to the device or reading from the device. So, this is a picture of the IO subsystem of a typical computer. Another important operation that is carried out by this IO subsystem is that whenever we want to transfer bulk of data, that is blocks of data from the devices like a disk or maybe a compact disk to the memory, it has to be done without disturbing the CPU. So, such operation is called direct memory access or DMA. So, this direct memory access is also taken care of by the IO subsystem of the computer. The combination of IO devices, device drivers and the IO subsystem comprises the overall IO subsystem of the computer. The purpose of the IO subsystem is to hide the device specific information from the operating system as well as the application developer, to provide a uniform access method to the peripheral IO devices of the system. We will conclude this session with parallel processing architecture. So far, whatever we have seen is about a single processor system, a basic system where a computer has a single processor, that is a single CPU. Now, to conclude the session, I would like to just give you a brief glimpse of how a modern advanced computer architecture looks like. So, here in all our modern computer architectures, we have advanced architectures, we call it the parallel processor. In parallel processing systems, we have multiple CPUs, say 2 or 4, and they are actually working in tandem, and the data or the program, they are shared by the multiple CPUs, so that the performance of the computer system as a whole is improved. So, here there is some responsibility rests on the programmer to identify or split the instructions that can be executed parallelly on the CPU, on different CPUs, or some modern compilers are very much intelligent enough, so that they themselves can automatically split the instructions and data for faster access, leveraging the multiple CPUs that are available on the system. So, in the figure you can see on the left, you can see a parallel system wherein we have 4 CPUs which share the same random access memory. So, such architecture is called centralized shared memory architecture. So, the number of CPUs exchanging information through the same memory. So, here the data is shared between all the CPUs, and it is the operating system which has to take care of the coordination between the CPUs and the memory. On the right you can see another architecture of a advanced computer system, that we call it the distributed shared memory architecture, wherein we have multiple CPUs and each CPU has its own main memory. Even though each CPU has its own main memory and cache memory, the operating system treats this distributed memory as a shared one and creates a bigger picture and uses interconnection network to coordinate between the workings of different CPUs. So, these two architectures are most prevalent in today's advanced computer architecture. Therefore, parallel processing, also called parallel computing, is a type of computation in which many calculations are carried out simultaneously. Large problems can often be divided into smaller ones, which can then be solved at the same time. There are several different forms of parallel computing: bit level, instruction level, data level, and task level parallelism. Parallelism has long been employed in high performance computing, but it is gaining broader interest due to the physical constraints preventing frequency scaling. Having multiple processing elements within a single machine, while clusters, MMPs and grids use multiple computers to work on the same task. Specialized parallel computers architectures are sometimes used alongside traditional processors for accelerating specific tasks. So, dear students, we have now come to the end of this module on building blocks of computer, and see you in the next module. Bye.